Welcome to CV 318. So, right in this video, we are going to be learning about these three topics, most especially this last two, singly reinforced and doubly reinforced. I'll be creating another video where I'm going to be giving you a brief teaching on nominal cover. So, if you are watching this video first, then I will want to refer you back to that video, nominal cover calculation. And if you can't get it, then you can easily read on nominal cover. Reading an omega cover is very, very easy and very straightforward. Very straightforward. So we're going to kickstart with singly and double reinforcement. So let's get started. So let's kickstart with singly reinforcement. So in singly reinforcement, compressive stress is applied in singly reinforcement. And in singly reinforcement, tensile reinforcement is not required. The singly reinforcement or singly reinforced beam, reinforcement is not required. Reinforcement is not required. So in simple term, in singly reinforcement, they're going to be having something like this: a singly reinforced beam, tensile reinforcement is not required. And this is known. This is known when K factor, when the K factor is less than 0.156. When the K factor is less than 0.156. So the 0.156 is talking about the normal reinforcement required in a beam. So when the normal reinforcement required in a beam is less than the 0.156 factor, then you apply it's a singly reinforced beam. But for a doubly reinforced beam, then reinforcement is required. That is, the K factor is greater than 0.156. So that is how to differentiate between singly and doubly reinforcement. So let me write it down. Doubly reinforcement also, reinforced beam, tensile reinforcement is required. So you might be told to do this in the exam to explain or differentiate between the two. So when k is greater than 0.156, then it is a doubly reinforced beam. It's a doubly reinforced beam. It's a doubly reinforced beam when k is greater than 0.156. So we're going to pick this one after the other. We're going to start with single reinforced beam, and then I'm going to tell you the steps involved in calculating single reinforced beam before we proceed to doubly reinforced beam, because this is the foundational knowledge you need to know before you proceed further. So this is the steps involved in calculating simply reinforced beam. So step one is to find your K. Step one is to find your K, which is M all over BD square FCU. M all over BD square FCU. Your M is talking about your moment. Your moment. You'll be given your moment. While your B is talking about the width. Your width. Your D is talking about the depth. So there might be a situation whereby you are not given your breadth and depth. So if you have watched the video on nominal cover, then you should be able to do this. So to calculate your depth is equal to I'm going to give you a formula. The formula is already written in the first video, which is the nominal cover section. But let me just give you the formula for D in case you are not given your depth, but you will always be given your depth. But in the case where you are not given your depth is your D is equal to your D will be cover or h minus cover minus link diameter minus bar diameter. So you'll be given your cover. If you're not given your cover, you use under the nominal cover. This is the nominal cover. The answer you get for your nominal cover, you'll be given your length diameter and you'll be given your bar diameter. So to find your depth, your height, you'll be given the total height of the beam. This is how the section of a beam looks like. I'll give you something like this. Give you something like this. So they'll give you the height, the total height, which is h, or your depth. Your depth is from here to here. This is your d. Why this is your b. From here to here is your b. So if you're not given your b, if you're not given your B, you'll be given your D. And if you're not given your D, you'll be given your H. Is that clear? So that is just how to do this. That is how to do this. So the first step is you find your K. Your K is talking about the K factor because it is your K that will help you know that, okay, this beam I'm working on is a singly reinforced beam or it's a doubly reinforced beam. But there's some questions whereby they will tell you it is a singly reinforced beam. So you can proceed with this formula. And there's some questions that will give you that won't indicate anything. So you have to be able to start from step one to be able to know that, okay, this thing is a single or a double reinforced beam. So number two is to confirm if your K is less than K prime. So if your K is less than K prime, that is 0.156, then you can proceed with Z. It's a singly reinforced beam. If your K is less than K prime is a singly reinforced beam, then you can proceed with Z. So the formula for Z is D into bracket 0.5 plus square root of 0.25 minus K all over 0.9. Your K is the K you get here. Your K is the K you get here for singly reinforced beam. But for doubly reinforced beam, the K here will be 0.156 if you're dealing with doubly reinforced beam. But if it's a single reinforced beam, you're going to use the K you get here. You're going to apply it, so then you calculate it to get your Z because it is that same Z you use in step 4. So for step 4, you find your area of reinforcement. AS is talking about area of reinforcement, area of tensile reinforcement, area of what? Tensile reinforcement. So you are going to calculate it, which is M all over 0.95 FYZ. We have FY, we have FC, we have FY, we have FSC. The FY is talking about the you'll be given your FY. You'll be given your FY. Your Z is your lever arm. Your lever arm. The FY should be, I think, compressive strength. Your compressive strength. Yeah. Your FY is your compressive strength. While your Z is your lever arm. Lever arm. Your FCU. Your FCU. Okay. Your FY is let me write it down. Your FY is FCU is for compression. FY is for tensile tension. You'll be given they'll say compressive strength, tensile strength. Compressive strength, tensile strength. So that's how to differentiate between the two. Compressive, tensile. So that's it. And after doing your AS, then you adopt using appendix 6. So these are some things I'm going to be explaining to you along the way. Use appendix 6 to do this. So this is the introductive part for singly reinforced beam. The introductive part for singly reinforced beam. So we're going to do a little calculation right now on singly reinforced beam so I can have more understanding on what we've been doing so far. Or better still, I can decide to move to W reinforced beam, then do the calculations later on. Is that clear? So let me write the steps involved for W reinforced beam also before we proceed. Is that clear? So for W reinforced beam, to calculate W reinforced beam, you have to follow these steps also. So step one, you have to find K equal to M all over BD square. The same procedure for single reinforced beam. So after doing that, the second step involved is to confirm if your K is greater than 0.156. In single reinforced, it has to be less, but in double reinforced, it has to be greater or equal to 0.156. Now, after doing that, step 3 is to calculate your lever arm, which is your Z. So now your Z is equal to 0.775D. That is, after calculating your Z, after applying 0.156 to this K, in single reverse beam, we are going to use the answer you get for K, we're going to apply it here. But in this case, no. You have to apply the answer you get You have to apply 0.256 as okay. So by the time you apply this, you're going to be getting 0.775D as your answer. And now the next step, which is step 4, is to find your d prime all over x. D prime over x. Now your d prime is cover plus length diameter plus bar diameter over 2. Also, if you draw you can be given your d prime. The d prime is from year to year. The d prime is always from year to year. The distance your from the top of the beam to the reinforced mat. So that is your d prime. That is the distance, the depth. So that's that for that. And also you proceed to step 5 to calculate your d prime. In case you're not given your d prime, but you'll be given it is cover plus length diameter plus bar diameter. But so if you give you a bar diameter, you give you a length diameter, so you can be asked to find the cover yourself. So go and watch the video on nominal cover. So to do step 5, you have to confirm if d prime over x is less than 0.37. I'm going to show you what the x means in the next video I'm going to do, most especially the calculative part. I'm going to have more understanding of what this terminology is involved. And also after confirming that, confirm if d prime over x is less than 0.37 or greater than 0.37. So if d prime over x is less than 0.37, so you use this formula. You first calculate the area of compression reinforcement before you calculate the area of tensile reinforcement. So I'm going to use this formula if d prime over x is less than 0.37, but if it is greater than 0.37, then you need to follow this. I'm going to clean this right now and put the formula there. So I want you to follow me carefully. So if your d all over x is greater than 0.37, then you are going to use this formula. A prime x equal to k minus k prime. Your k prime is talking about the answer you got for your k, the first step. The first step that is talking about your k prime. And bd square over fcu, or your K prime is talking about 0.156 rather. Your K prime is talking about 0.156. Please take note of that. K prime is talking about 0.156. And your normal K is talking about the answer you got in step 1. The answer you got in step 1. So for your step 2, for your lever arm, it's supposed to be K prime and not K. That is 0.156. Sure you got 0.156 for your lever arm. So for this, you're going to use this BD square FCU. The FCU you'll be given, and then FSC is the formula for FSC, which is E times YCS. And your YCS is 0.035 times X minus D prime all over X. And your X is D over 2, your depth divided by 2. That is your X. The depth divided by 2 is your X. To prove it, D prime all over X told you x is d all over 2. So take note of this. These are very, very crucial. Write this down and let this take into your head. Share that. And also, your E is 200,000. So after calculating your YCS, just multiply it by 200,000. As simple as that. So that is how to find your FSC. And now, find your D and still find then calculate. So these are how to do it. And after doing this, then you adopt. That's the last step. That's the last step, which is step 6, adopt. So I think you've been able to jot the single reinforced steps and the doubly reinforced steps. So as time goes on, we're going to be doing some tough calculations and we're going to be treating this and we're going to be crashing this. This is a very, very simple topic that you actually need to master. A very simple topic, and I believe if you can master this, then you are very good. You'll be very, very good in any solving any exam questions. Is that clear? So let's dive into the calculation aspect. So now we're going to be solving a simple mathematical equation. So I've been given our M, which is our moment. We're given our FCU, which is the characteristic strength of concrete. And we've been given our FY, which is the characteristic strength of reinforcement. And we'll be given our D, which is the depth. And we'll be given our breadth, which is the width, our B, which is the width. So the step 1, I love to solve my calculation in step. I just write step 1, step 2, step 3, step 4, step 5, step 6, up to step 10. So for step 1 is to find your K according to what I give to you. Find your K, which is M all over BD square FC. And we'll be given our M as 150 kilonewton meter. To convert Newton to meter, kilonewton meter will give you times 10 raised power 6 millimeter. 10 raised power 6 Newton millimeter. Anything times 10 raised power 6 Newton millimeter. So we are going to put it here times 10 raised power 6 Newton millimeter all over BD square. So our BD square is, your B is 200, B is 387 mm multiplied by our FCM, which is 40. So our K will be giving us, you can press it in your calculator, your K should give you 0.125. 125. It's a factor. So our step two is to do what? To confirm if K is less or greater than 0.156. So our K is less than 0.156. That is 0.125 is less than 0.156. Therefore, it's a singly reinforced beam. The singly reinforced beam. Most of the questions that were set in the exam will should be singly reinforced beam, not double. Check that. But I'm going to teach you the two. Check that. So step three is to do what? Step three is to find your Z, which is your lever arm. Find your Z. And formula for Z, based on what I gave you earlier, is D into bracket 0.5 plus square root of 0.25 plus K over 0.9. So we are going to apply a K there. So our D into bracket 0.5 plus square root of 0.25 plus 0.25 should be minus, sorry about that, minus, so our K is 0.125 all over 0.9. Do you get? So our final answer should be something around 0.83 D. So you can decide to continue solving, which is 0.83 times. What is our D? Which is 387. Just to get 7. So you can decide to continue solving to arrive at your Z. So for step 4, our step 4 is to now find our area of reinforcement. Our area of reinforcement, which is our AS. And to find your AS is what? So based on what I gave you earlier, your AS is M all over 0.95 FYZ. M all over 0.95 FYZ. And our M has been given as 150 times 10 power 6. And our 0.95. So our FY has been given as 460 multiplied by 0.83 D. 0.83 D. 0.83 D. I hope that is clear up to that particular point. I hope that is clear. 0.83 D. 0.83 D. So can continue calculating as 150 times 10 raised power 6 all over 0.95 times 460 times 0.83, and our D is what? 387. So your final answer should be around, final answer should be around, final answer should be around 1068 square. We are dealing with area. Area, the unit of area is either meter square, centimeter square, millimeter square, but that's with square area, depending on what you are facing. If you are facing area of reinforcement facing always in millimeter square. So the next step is to do what is to adopt. And now to adopt, I've created a special video on how to adopt. It's very, very easy. Just take your appendix 6, appendix 6. Now look for where you can see 1068 millimeter, somewhere or something closer to it or something more than it. Sure you get. Now, by the time you shake something more than it, now look at, for me to top, it can be 4 by 20, it can be 5 by 25, it can be 5 by 30, it can be. So just look at something like that. So for me, I would say adopt 4 by 20 mm diameter, providing 1260 mm square. So I'm using something like 1260 mm square, 1260 mm square for my own shade. So for your own, you can try to use something closer to it or something more than it. Anyone shade that's you're still correct. So as simple as that. So I believe you've been able to understand singular first bin. Share that. So the next question I'm going to be dealing with is the W first bin. You understand? Forget about the slab. Share that. Forget about the slab. It won't come out. It will only come out for a certain topic that I'm going to walk you through in the next video that I'm going to be doing for you also. So I believe you've been able to understand this. So if you have any further question, always drop it on the group and I'll definitely answer you. Or you come to my DM and I will answer you. So I believe this is clear enough. Hi guys, this is another question, and we're going to check if it is either simply or double first B. So, based on what we can see, you can see that M is given, FC is given, FY is given, and here is your D. That is from the height of the bin down to the first tensile reinforcement. That is your D, and our D prime has also been given as 50, and our breadth has also been given as 300. So, step one, based on what I've given you so far, step one is to find your K, which is M over KD square FCU. So our M is 600 times 10 raised power 6. You have to convert it to millimeter, that's times 10 raised power 6, Newton millimeter. So you have to convert it. So having this, all over, our B is given as 300 and our D has been given as 444 times FC has been given as 40. So by the time you calculate it, your K will be giving you 0.225. So which will lead you to step 2, which is confirmed. So our K is greater than 0.225. Our K is greater than 0.225. And that is, it's greater than 0.156. 156, that is 0.225 is greater than 0.156. Hence, it is S. W with first A. Hence, it is a W. It is a W with first B. So we have to move to the next part, which is step 3, which is to find your lever arm, which is what? Z. So our Z is equal to 0.775D, which will be equal to 0.775 times our D is 444. So your Z should give you something like 346, 346 point, 346.3, and this has been calculated. You understand? When I was explaining, I said your Z is equal to D into bracket zero point 0.5 plus square root of 0.25 minus K prime over 0.9. So your K prime is 0.156. By the time you solve it, you are going to arrive at this. Then you apply your T, then you solve, then you get this. So the same thing. And then step 4 is to find your what? Is to find your D prime over X. D prime over X. And I've already told you, you should check if a D prime over X is greater than 0.37 or less than 0.37, greater or less than 0.37. So you can continue by saying x is equal to d over 2 or 0.5d. So our d over 2, which is 444 all over 2, which is equal to 222 m. So you can put it here and say d prime all over x equal to 50 all over x, which is 222. 50 over 222, that should give us 0.23, 0.23. So the next step, you see that 0.23 is less than or equal to 0.37. It's less than or equal to 0.37. It's less than or equal to 0.37. It's less than or equal to 0.37. So we're going to be applying the first formula I gave to you. So I'm going to work this off and then I'm going to proceed with what I have for you. Is that clear? Now that we've climbed that, so that should be under step five. Step five. I believe you can see what I'm writing. Should be able to see that. Step five. Um, Find your AS prime, area of compressive reinforcement, area of compressive reinforcement. And our formula is, in a few minutes. Okay, our formula is equal to K minus K prime is equal to FCUBT square all over 0.95 Fy to D minus D prime. So by the time we solve, our K is the answer we get earlier, which is 0.25 minus 0.156, which is our K prime, multiplied by our F, which is 40, and our B is 300, multiplied by 444 square. Always put the square. The square is very, very important. This is one of the biggest mistakes men do perform in exam. They forget to put the square. Please always put the square. Very, very important. And also, let me write it. 40 times 300 times 444 square. That's 444 square. So, please pay attention to that. If you can't see it, let me know. 444 square. So, all over 0.95 times 460. 60. So, D. So, our D is 444 and our D prime is 50. So by the time you calculate it, your AS prime will be giving you 1067. So then you can proceed to AS. Proceed to AS, which will be, I've given you the formula also, so you can check the formula book. Our AS should be K prime, FCU BD square all over 0.95 FYZ plus the answer you get here, which is AS prime. AS prime. So by the time you calculate, your K prime is 0.156, that's constant, multiplied by FCU, which is 40, multiplied by B, which is 300, multiplied by B, which is 444 square, all over 0.95 times Fy is 460, right there, multiplied by Z. The Z we got earlier, which is our liver arm, we got 346, 346 point three. So by the time you solve, your AS should be giving you something like um give something like 38 3811 millimeter square. Don't forget to add this to it. 1067. Add that to it, please. And stop. So then the next step is to do what is to adopt. So if you check your 36, the one that is closer to 3811 is the one that's closer to it is I think 3930. 3930 is the one that is closer to it in appendix 6. So I would say adopt 8 by 25 because it falls under 8 by 25. 8 by 25 mm diameter high yield strength bars, HYS bars, providing 3930 square. So that is how to adopt. That is how to adopt. Adopting is a very simpler thing to do. So I believe you've been able to get how to do this. Is that clear? So if you have any further questions at the end of this video, please let me know. So I've been able to trash out um, different problems on singly first and doubly first. So these three examples, by the time you master, implement, master, we do and we do, you should be able to have more precise understanding of this. Is that clear? So I believe I've been able to give you some information on singly and double reinforcement. So for nominal cover, I'm going to be walking you through a video on that. So try to watch the video. Check it. Try to watch the video. Nominal cover is mostly to calculate the cover, to calculate your D, and to calculate your breadth, most especially this also. So I'm going to be teaching that in an another video. So thank you for your time. So I believe you've been able to get something. So thumbs up.